Computers, they're everywhere in modern society. From your iPhone in your pocket, to a Mac, to a Windows computer, to smartwatches, they're everywhere. So this is my attempt at understanding how computers work, understanding registers, ALUs, and making something that's actually useful for real life using basic computers and basic logic. And this is in a simulation, so I can tweak the design first before actually making it in real life. And this is my design right here. So basically, it is a digital clock made from basic logic gates from Sebastian's Logic Simulator. Very cool. And you see it adds numbers. And once it goes over 59, it adds a number in the hour spot using only logic gates and basic computing elements. So let's dive in to see how this works. So first off, we're going to go to the minutes, because the minutes, it's way more complicated, and we're going to see how it works first. So this is it. So in order for something to be defined as a computer, it has to process, store, and fetch data. So this is how we store data on our register. A register allows you to store data. Look with this, you have the store pin, so it allows you to store data. We're going to store 6 bits of data, because you need 6 bits at least to represent 60 in binary, which is standard for clocks. And then we have a 6-bit 1-bit adder. Since we're not adding more than 2, like a clock only adds 1 decimal value or 1 value every 60 seconds. We only need to add by 1. We don't really need to add by any other number. So a full adder is not necessary for this circuit. That can save on transistors if you actually want to make this. But if you want to design it to run other programs, you're now limited. But I'm not doing that. And then this is the logic right here, where I know, is it 60? So if it is 60, we're going to reset this whole thing. And if you go back to the register, we have these reset pins, which are just OR values. And if the reset tab is high, then it's going to fill up everything, which is going to equal 64 plus 1, which is 65, which can't be stored in 6 bits of data. So it's going to automatically reset this ALU. And this NOT gate right here, the purpose of that is so that this 1 is constantly on, so we're constantly adding my 1. If you made this in real life, all you have to do is put this up to the 5-volt rail on your breadboard. So that's how you do it. And if you can read binary, then you don't need this graphics area. But if you want a 7-segment display, you're going to need this. So Sebastian, whatever his channel is, I'll put a little thing up. He made a great tutorial on how to represent data using logic gates into binary. And he used a program called, it's famous, all people use it, it's called Double Dabble. But I'm not going to explain it too much right now. But basically, if the number is over, I think 5, the program's going to add 6 to it. And when it adds 6 to it, it's automatically in binary going to put the correct spot in the 1's place, and then in the 10's place, or this is the 10's place, and then the 1's place. So then you have that, and then you have to convert the 4-bit binary number to decimal, which is what this big thing does. And then after that, you can display it on a 7-segment display. And then this is the logic to let me know, is it 60? Because once this reaches 60, we need to update our hours system, so it can add by 1. And the hour system is super simple compared to this. So all we have is this 4-bit register instead of 6-bit. This is the reset program right here. And then we have our 4-bit adder, which are still all half adders. And this is the logic to let us know it's 12. And we only need 1 AND gate because 8 plus 4 is 12. The NOT value still does the same thing, so we can add by 1. And then the 4-bit graphics is even less. We only have 1 dabble, 1 binary to decimal computer, and that's it. And that's how it works. So as long as the store is high, and every time the clock runs, as a number. I don't know if this is the most efficient way to make it, but this is my design that I made, and it works very well in the simulation. So I hope to make this in real life one day, and yeah, see if I can actually build this. If you want to know more information about computer architecture and how it works, like I said, you can look at Sebastian's channel, or I can make my own videos. But yeah, I think computer architecture is very, it's so interesting how we can trick electricity into solving all of our math problems just by using silicone. It's kind of wild to me that we can do this. So in the next few months, I'm gonna spend a lot of time really learning how to make this. I don't even know what you can call it, like a 6-bit, 4-bit computer type thing, but it's really a digital clock. And I'd rather make this than a standard 4-bit computer, because this is more useful in my opinion. And a 4-bit computer, like, all I'm going to do is be able to add like 9 plus 9. I don't want to do that. That's completely useless. I want to do something that actually store meaningful data for me to use. Even though this won't be as efficient as modern day clocks, I think it's still going to have this cool look, just seeing a whole bunch of transistors and actually seeing what time it is.